This video's been made to instruct the technicians and staff in charge of servicing the Sorento part-time four-wheel drive system. Throughout this video, you will learn how the Sorento four-wheel drive system operates and what happens when the system fails. This information will help you diagnose the system efficiently. The Sorento part-time four-wheel drive video includes the following content: EST system, EST components, power flow, inputs and outputs, failsafe. Now let's take a look at the Sorento EST system. There are two types of Sorento four-wheel drive systems. One is a part-time four-wheel drive, and the other is a full-time four-wheel drive. Both are made by Borg-Warner Torque Transfer Systems in the USA. The part-time four-wheel drive system, which is equipped as standard, is called the Electric Shift Transfer, or EST. The full-time four-wheel drive system is called the Torque on Demand, or TOD. Now let's look at the EST transfer case. The chain is adapted to transmit torque to the front shaft. The oil pump lubricates operating parts, and the lubricant is Dexron 3, which is also used for Sorento AT oil. The planetary gear set is used to increase the transfer output torque when the four-low drive mode is selected. The Freerunning Differential, shortly called FRRD, is incorporated as a shift-on-the-fly system, which disconnects torque between the transfer case and the front wheels when the vehicle is in the 2H mode. Different from a freewheel hub type, which has been used for the Sportage, the FRRD is positioned inside the front differential to disconnect the front propeller shaft from the front axle. The 2H mode is the normal driving condition with rear wheel drive on. The 4H mode is used to increase drive torque and to get more traction on off-road or on slippery road conditions, such as snow-covered or wet roads. The 4-high lamp stays on when the 4H mode is successfully engaged. When the vehicle is driven on dry pavement, the drive mode is likely to be in the 2H mode. Otherwise, vehicle vibration and noise will occur on a U-turn or while making a sharp turn at low speed. And now let's see why this happens. During vehicle steering, the front wheels travel farther than the rear wheels, resulting in a speed difference between the front and rear wheels. When a part-time four-wheel drive vehicle is running in the 2H mode, the speed difference between the front and rear wheels does not affect them. However, when a vehicle is in the 4H mode, the front and rear wheels are mechanically connected to each other. So faster front wheels makes the rear wheels slip on dry pavement, resulting in an uncomfortable vehicle vibration and noise, which is known as tight corner braking development. The 4L mode is likely used for climbing a rough slope when the vehicle requires high torque. When shifting to the 4L mode, the four-wheel drive low indicator stays on, and overdrive speed is inhibited by the TCM in the case of an automatic transmission. Shifting between 2H mode and 4H mode is available while driving under 80 kilometers per hour. For shifting between 4H mode and 4L mode, there are two conditions. First, stop the vehicle. Secondly, press the clutch pedal for manual transmissions, or position the shift lever to N for an automatic. So far, we have briefly shown the EST system. From now on, let's look at the EST components and its functions in detail. There is the planetary gear and the main shaft, which transfers transmission output to the rear shaft. The planetary gear is connected with a main shaft through a reduction hub. The reduction hub is splined to a planetary sun gear or a planetary carrier by positioning the reduction fork. When the reduction hub is connected with the sun gear, the transfer output gear ratio becomes 1:1. However, when it's connected with the planetary carrier, the transfer output gear ratio becomes 2.48:1. The oil pump connected with the main shaft lubricates moving parts inside the transfer case. Now let's see the shifting parts which are engaged while shifting from 2H to 4H. There is the EMC housing splined to the main shaft, which transmits driving torque to the rear wheels. The lockup collar, lockup hub, and lockup fork are engaging parts to connect the EMC housing and the upper sprocket. The upper sprocket, connected with the metal chain, transmits driving torque to the front wheels. The shift motor is connected to the shift cam. The shift motor rotates and stops at the 2H, 4H, or 4L positions according to the EST switch selection. While the shift motor rotates, the shift cam also rotates, allowing the reduction fork and the lockup fork to move properly. The EST shift motor looks like the TOD shift motor, but its function is different. So when a shift motor is exchanged, make sure to order a correct EST shift motor. The electromagnetic clutch, shortly called EMC, is a stationary part fixed on the transfer housing. The EMC coil is energized when the EST switch is shifted from 2H to 4H. At this moment, the shift motor begins to rotate, moving the lockup fork and the lockup collar. The lockup collar, moved by the shift motor, stops about 3 millimeters before the EMC housing. Then it is completely engaged with the EMC housing by the magnetic field generated by the EMC coil. The drive chain is connected with the upper sprocket splined to the main shaft and the lower sprocket splined with the front output shaft. The drive chain should be installed in the same direction. The blue mark faces the rear shaft. The Freerunning Differential, which is called the FRRD, is incorporated in the Sorento EST system. The FRRD system consists of a free-running differential and an air pump motor in the engine compartment. Differently from the conventional differential, the FRRD has a dog clutch which is coupled to the differential housing and an actuator which pushes the dog clutch. Moreover, the differential pinion shaft is not fixed on the differential housing and it rotates freely in the 2H mode. However, when the 4H or 4L mode is selected, the FRRD air pump motor generates air pressure to operate the actuator, which pushes the dog clutch. The differential pinion shaft is coupled to the dog clutch, which is fixed on the differential housing. The FRRD functions as a conventional differential. In the 2H mode, the FRRD air pump motor is not activated. and the dog clutch in the FRRD is not engaged. At this moment, the pinion shaft is not fixed on the differential housing, and it rotates freely. So the torque connection between the front axle, which is connected with the side gears of the FRRD, and the front propeller shaft, which is splined with the FRRD housing, is disconnected. So far, we have learned about the EST construction and its components. Now let's take a look at how power can flow to the rear and to the front in the EST transfer case. In the 2H mode, transmission output comes through the transfer input shaft and is directly coupled with a main shaft by a reduction hub. The drive chain is not connected with the main shaft, therefore the transmission output only goes to the rear wheels. When the 4H mode is selected, the shift motor and the EMC coil are activated. When the lock-shift fork moves, the lockup collar approaches the EMC coil housing. The upper sprocket is coupled with the EMC coil housing and begins to rotate with the main shaft. The other side of the drive chain is connected with the lower sprocket connected with the front output shaft. So the driving torque from the transmission is split in two. In the 4L mode, power flow to the front is like in the 4H mode. However, the main shaft is coupled with the planetary carrier by the reduction hub. At this moment, the transfer output gear ratio changes to 2.48 to 1, providing higher torque to the front and the rear wheels. Now let's study the input and output of the EST system. Before we learn the function of inputs and outputs in detail, let's find out what the different kinds of inputs and outputs consist of. The inputs of the EST system are the motor position sensors, the EST switch, the in-range signal for the automatic transmission, the clutch interlock switch for the manual transmission, and the rear speed sensor. The outputs are the shift motor, the electromagnetic clutch, the FRRD air pump motor, the 4-high lamp and the 4-low lamp on the cluster. Now let's look at the input and output factors in detail. The motor position sensors, which are also called position encoders, inform the EST control module of the shift motor operation and its position. The motor position sensor part is a part of the shift motor assembly. The sensor part contains 5 terminals, such as the motor position 1, 2, 3, 4, and the common return. When the ignition is on, around 5 volts flows to the position 1, 2, 3, and 4 from the EST control module. The current that flows to the motor position sensors returns to the common return through a metal plate. When the EST system is in a normal condition, the common return terminal is not grounded by the EST control module, so 5 volts are detected at the common return terminal. When the drive mode is changed, the shift motor begins to operate, and the EST control module grounds the common return terminal for 7 seconds. The common return output voltage drops to 0 volts during that time and comes back to 5 volts when the ground is cut off by the EST control module. While the common return terminal is grounded, output voltage at the positions of 1, 2, 3, or 4 can drop to 0 volts if it contacts the metal plate, which is also grounded by a common return terminal. The position sensor output voltage comes back to 5 volts when the sensor loses contact with the metal plate or the common return terminal is not grounded. If a failure is detected, both the 4H lamp and the 4-low lamp come on. The EST control module grounds the common return terminal, which contacts the metal plate. At this moment, output voltage of the motor positions which are in contact with the metal plate drops to 0 volts. The EST switch informs the EST control module of a selected drive mode. The EST switch has 3 selections: 2H, 4H, and 4L. However, only the 2H and 4L switch terminals are connected with the control module. The control module allows 5 volts for the EST switch. If the 4L mode is selected, the 4L switch terminal is grounded, so the 4L terminal output voltage drops to 0 volts. If the 2H mode is selected, the 2H terminal of the EST switch is grounded, so the 2H terminal output voltage drops to 0 volts, informing the EST control module that the 2H mode is being selected. When the 4H mode is selected, the 2H terminal and the 4L terminal of the EST switch are not grounded, so the output voltage of both terminals is 5 volts, informing the control module that the 4H mode is being selected. If the 4H mode is engaged successfully, the 4H lamp comes on in the cluster. The output voltage of the 4H lamp terminal drops from 12 volts to 0 volts. If the 4L mode is engaged successfully, the 4-wheel drive low indicator comes on in the cluster. The output voltage of the 4-wheel drive low indicator terminal drops to 0 volts from around 12 volts. If the EST system fails and both the 4H lamp and 4-wheel drive low indicator illuminate, the output voltage of both terminals keeps at 0 volts. The N-range signal is required for AT models to shift from 4H to 4L or from 4L to 4H. When the shift lever is in the N-range is grounded and the output voltage from the control module drops to 0 volts. The output voltage comes back to 5 volts in other ranges. The clutch interlock switch is required for the MT model to shift from 4H to 4L or from 4L to 4H. When the clutch pedal is pressed, the switch is grounded and the output voltage from the control module drops to 0 volts. The output voltage comes back to 5 volts when the clutch pedal is released. The rear speed sensor is an inductive type. A 5-volt monitoring voltage is detected from the sensor terminal after the ignition is turned on. If the system fails and the warning lamps are on, the output voltage drops to around 1.2 volts. The shift motor has 2 wires. When shifted to other modes, one wire is grounded and the other is energized by the EST control module. When the shift motor needs to rotate in the opposite direction, the motor terminal phase changes. That is, the grounded wire is energized and the energized wire is grounded. The electromagnetic clutch coil is energized for 11 seconds by the control module while shifting from 2H to 4H. The FRRD air pump motor operates during the 4H or 4L modes. In the 4H and 4L mode, around 12 volts flow to the FRRD air pump motor and a release valve. The air pump motor supplies air pressure to the FRRD actuator. There is a pressure switch in the air pump motor, which is turned off when the generated pressure reaches 0.38 to 0.58 kilograms per centimeter squared. If the pressure switch is off, the FRRD air pump motor stops. However, the generated pressure is held by a release valve. If the FRRD actuator pressure decreases, the FRRD air pump motor begins to operate to generate proper pressure. In case of an air leak in the lines between the motor and the actuator, or in the FRRD actuator rubber seal, the FRRD air pump motor keeps operating to generate air pressure. When the FRRD air pump motor operating sound is heard all the time, air leaks need to be checked. When the 2H mode is selected, the EST control module cuts off power to the FRRD air pump. Output voltage from the diagnostic display terminal is normally around 4 volts. When a problem is detected and the warning lamps turn on, output voltage has a pattern at the beginning after the ignition key turns off to on, and then comes back to 4 volts constantly. In the case that the HiScan Pro cannot communicate with the EST control module, the output voltage from the diagnostic display terminal needs to be checked, as well as the continuity of the wire harness between the EST control module and the 20-pin diagnostic connector. The picture shown is the output voltage from the damaged EST control module. The output voltage is approximately 1.2 volts. It doesn't show any voltage pattern when the ignition key is turned from the off to on position. So far, we've seen the EST inputs and outputs. Finally, let's take a look at the failsafe function of the EST system. The EST control module provides a self-diagnosis function and binary trouble codes to be read through the HiScan Pro. Trouble codes can be read from the 20-pin diagnostic connector in the engine compartment. However, the codes cannot be read through the OBD connector in the cabin. To read trouble codes correctly, the instructions shown on the HiScan screen should be followed. To demonstrate the EST failsafe function, such as the warning lamp control, the transfer control, and the trouble codes, we will intentionally make some problems. A terminal from the shift motor connector and the EMC coil connector on the transfer case will be removed one by one. Regarding the motor position sensors, there are 5 terminals, that is, the motor position 1, 2, 3, 4, and the common return. Now, each terminal is removed and checked for failsafe function. Except the position sensor 3 open, which allows shifting between 2H and 4H. The trouble is detected as soon as shifting from 2H to 4H, and the trouble code is 111. If a failure is detected, the 4H lamp and 4-wheel drive low lamp are turned on, and shifting to other modes is not possible. The transfer case does not move when a failure is detected. For example, a position sensor failure is detected while driving in the 4H mode. The transfer is fixed in the 4-wheel drive state, transmitting the torque to the front shaft. However, torque cannot be delivered to the front wheels because the EST control module inhibits FRRD air pump motor operation if a failure is detected. If the 4WD low lamp comes on because of a failure, 4th gear is inhibited by the TCM in the automatic transmission. If motor position 3 is open, failure is not detected while shifting between 2H and 4H. However, the failure is detected while shifting to the 4L mode. In case of a rear speed sensor open or short to ground, failure is not detected in the 2H mode. However, the failure is detected when shifting to the 4H mode. When the failure is detected, the 4H lamp and the 4WD low lamp come on, and shifting to the other modes is not available. Trouble code 100 is displayed. The next problem is the EMC coil open or short to ground. The failure is not detected in the 2H mode. However, when 4H mode is selected, the failure is detected because the EST control module monitors the EMC circuit while activating the EMC coil. When the failure is detected, the 4H lamp and the 4WD low lamp come on, and shifting to the other modes is not available. The trouble code 011 is displayed. When the circuit of the FRRD air pump is open or short to ground, the failure is detected while shifting from the 2H to 4H modes. The 4H lamp and the 4WD low lamp come on, and shifting to other modes is not available. Trouble code 101 is displayed. And lastly, if the shift motor fails, the failure is detected and both lamps come on. Shifting to other modes is not available, and the corresponding trouble code is 010. HiScan provides the trouble code reading, but the trouble code cannot be erased by the HiScan Pro. To erase it, turn the ignition off and make a short circuit between pin number 4 and pin number 8 of the 20-pin diagnostic connector with a jumper wire. Turn the ignition on and wait for 10 seconds, and make sure that the trouble code has disappeared. If not, try it again after fixing the problem. So far, we've studied the Sorento EST system, mechanically and electrically. I hope this video will be very helpful for you to diagnose the EST system in your workshop. Thank you.